All right, so here we're going to use the four-step process to find a derivative. So one can find that the derivative of a constant times the differentiable function is the constant times the derivative of the function. So instead, we're just going to state the theorem below. Okay, so what happens is, again, if we have some y is equal to f of x, and that's equal to some k times u of x, then what we can do is we can find f prime of x is equal to k, we're just going to pull it out front, times the derivative of that function, u prime of x. And another way to write it would be y prime or dy dx. And so that's going to be how it is. And then the du dx means we're going to take the derivative of that with respect to x. So how does that look when we actually do problems? Well, for A, what we're going to do is we're going to say, okay, well, let's pull this out in front. And so really what we have is 4, and then we have the we want to find the derivative of the x to the fifth. So this part is the constant out in front. Now we want to find the derivative of that. So finding the derivative of that, we're going to take that, bring it down in front. So f prime of x is going to be 4 times 5 times x to the 5 minus 1 is 4. Well, 4 times 5 is going to give us 20x to the fourth. All right, what about this one? Well, that really is going to be a 1/12 times a t to the fourth. So we just take the derivative of that. Well, we take that, bring it down in front. And so let's do b here, I guess. So we're going to have dy dt is equal to 1/12 times. Now we'll have a 4t. Now we subtract 1 here, and that's going to be a 3. Well, now we can reduce. 4 will go in here once, 4 will go in here 3 times, and so we end up with just a t to the third over 3. All right. What about this one? Well, again, we can just rewrite that as 1/3 because that's the kind of the number part of it. Now, this is the x to the third on the bottom. So if we take it and put it into the form where we have x to the n, this is going to be x to the negative 3. And now we can take this derivative, bring that down in front, subtract 1. And so for c, we're going to have y prime is equal to 1/3 times negative 3x to the negative. Well, minus 3 minus 1 is going to be minus 4. Now this one, this becomes a minus 1, that becomes a 1. And so really all we have then left is minus x to the minus 4. And again, if we write that as a positive exponent, it's going to be a minus 1 over x to the fourth. Okay. Now for the last one here, we are going to rewrite this on the denominator. So that's going to be 0.9 over, and that's going to be x to the 1/3. Well, we want that to be in the form like this. So that's going to be 0.9 times, that's going to be x to the negative 1/3. Now we can take that derivative. We'll take that again, bring it down front and subtract 1. So d will have a 0.9. And we're just kind of taking the derivative. And this is just showing what the derivative is. We don't have all our d's and stuff on there, but that's okay. Times, and we have a negative 1 over 3. Then x minus 1/3 minus 3/3 more to get the common denominator. So that's going to be a minus 4/3. And that's going to be that. Now, what we can do is we can take 3 goes into here. That's going to be 0.3. And so now it looks like we have a negative 0.3. Then we have x to the negative 4/3. Well, again, we want that to be a positive, so that's going to be a 0.3 negative all over. Now, this is the cubed root of, so cubed root of x to the fourth. And that then would be our final derivative, d dx of our 0.9 over the cubed root of x. Okay, so that would be our final value there. All right, so let's stop there and we'll come back for more.